Okay, this is the recording for the topic 3 assessment for Algebra 2. So this is the review paper that you should all have. If you don't have it and you need another one, let me know. So what I'm going to be doing with this assessment, different from what I did in what we did in class, is I'm actually going to go in order of the questions. So, yep, here we go. So I'm just going to jump right into it. So the first question is asking what is the remainder when this polynomial is divided by x minus 3. So there are a couple different ways of doing it. One of the ways of doing this particular problem is very specific to this problem. And I'm going to show that second. Let me show this one first because I think this is better. So here's the very same problem. So what you'll do is you'll set it up like this. You will put the x plus 3 right here. And then you're just going to put this first term, this x to the fourth, in this box. And then the next thing that you do is you're going to divide. So the steps are going to be divide, multiply, and then figure out what completes the number. And then you do it again. Divide, multiply, complete the number. Divide, or to complete the term. Divide, multiply, complete the term until you're out. So we start with this number, the first term in this upper left box right there. And then we ask, how many times does x go into x to the fourth? Or x to the fourth divided by x is what? And that would be x to the third. So that was the dividing part. I put my answer up there. And then I multiply this x to the third by the 3. So it'd be 3x to the third. So that's the multiply and the divide and the multiply step. And then the next part is we ask, what do these two have to add up to? Those two have to add up to the term with the x cubed up here. And that's what you would put in this box right here, like in this one right here. However, with this particular problem, it's got an issue because there are no x cubes. What that means is there are 0 x cubes. So in order to make a 0 term, you would need opposites. So it would make a 0 pair. So we would put, so this is positive 3x cubed. So what's the opposite of positive 3x cubed? That would be negative 3x cubed. And then we combine that. And then, okay, so then that was that. So that was the divide, the multiply, and then completing that number. Okay, the next step is we'd go again. What do we have to multiply this x by to get negative 3x cubed? Well, it's going to have to be negative 3x, but then it'd be squared, right? Because if we multiplied, it would be x times x squared. It would be x cubed. All right, now we are going to multiply. Negative 3x squared multiplied by the 3 that's over here would be negative 9x squared. And now we're going to, so that was the multiplying part. Now we're going to finish the term. So the term that we're aiming for is negative 8x squared. We have negative 9x squared, but we want negative 8x squared. So we would have to add on one more x squared in order to complete that, to make that finalized, right? So that was that part. Now we're going to go to the next term, and that would be, so we're going to ask what we have to multiply x by to get x squared. That goes at the top. It's just x, but it would have to be a plus x. Then x times by 3 is 3x. Now these two would combine, and they're going to equal this 10x, right? So then I would put, so I already have 3. How many more do I need to get 10? I need 7 x's. So that was that part. And then x times by what goes at the top to make 7x? Well, that would be plus 7. And 7 times 3 is 21. And then we're out of the terms, basically. Now what we would do is, I know that these two would combine to be that. And what I would need here would be a plus 1, and this number is the remainder. This is the remainder. And then just, yeah, so that's what we do. That would be the remainder. If we had to keep on doing this problem, which you are later on, what you would do with that remainder is that remainder would make a fraction with the remainder being in the top in the numerator, and then the divisor, this x plus 3, being in the denominator. Divisor, denominator. I mean, yeah, divisor would be in the denominator and remainder would be in the top. Yeah. The other way, just so that you have another way of doing this, the other way of doing this problem, if you wanted it, is you're going to take the opposite of the plus 3, and so you would take negative 3, and you would put it in place of all of the x's in this problem, and then calculate that out, put it in the calculator, and figure out what it would be. So it would be negative 3 to the 4th minus 8 times negative 3 squared plus 10 times negative 3, and then plus 22. If you put that in, you would get 1. So that's another way of doing it. That's very specific for this problem. The box way that we just used fits for 3 of the problems on this test. That's why I did it this way. Okay, and then let's check the time. Oh, okay. All right, so that was number 1. Whew. Okay, number 2 is dumb. I don't like it, so just write down this thing. So the answer is going to be all real and rational numbers, because the question doesn't make sense / it's super hard. Number 3 is you're going to use the binomial theorem to expand this polynomial, this binomial. So what we're going to have to do is expand Pascal's triangle. So as a reminder for how to get Pascal's triangle, the numbers in Pascal's triangle, we're going to take the 1 and the 3 and add them together, and it goes in between them underneath. So that would be a 4. Oh, we always have to start with 1. And then 3 plus 3 is 6. And then 3 plus 1 is 4. And then there's a 1 right there. And we have to keep on going until the second number in is a 6. So we're going to have to do 2 more rows. So 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then 1. And now we want, this is the one that we want. We want 1 and 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15 again. 5 plus 1 is 6, and then 1. So get to the Pascal. So the first step is get to where you need to go in Pascal's triangle. Second step is you're going to write those numbers out really spread apart. So 1 and then 6, leave some space, 15, leave some space, 20, space, 15, space, 6, and space, and 1. The next step is we are going to take the number on the left, and we're going to put it to this power of 6, and then we're going to put it to the power of 5, 4, 3, 2, 1, going from the left, the number on the left, from the left going down. So this will be 2x to the 6th, 2x to the 5th, 2x to the 4th, 2x to the 3rd, oops, 2x squared, and 2x. And then there was the 1, but we don't need to put anything there because that would be 2x to the 1. And we do the same thing with the number from the right. So we're going to take that negative 2 from the right and put it to the power of negative 6. So negative 2 to the 6th, negative 2 to the 5th. So 5, 4, 3, 2, 1, but going from the right. Negative 2 to the 4th, negative 2 to the 3rd, negative 2 squared, and negative 2 to the power of 1. Whew. Now, everything from here on out is going to be multiplying and using a calculator to be able to get the numbers here. Yeah, so it goes like this. So you're going to need a calculator such as, that's my daughter's funny thing. Okay. Such as, so we want 2 to the 6th. I like how slow this is right now. Awesome. Okay. So 2 to the 6th is 64. So we have 64x to the 6th. And then I'm going to do, now what I'm going to put in the calculator is 6 times 2 to the 5th times negative 2 to the 1st. And in fact, I'm going to type everything except for the x, and I know that my x term is going to be x to the 5th. So now I'm just doing the numbers, and I need to check if it's positive or negative. So 6 times 2 to the 5th times negative 2 to the 1st. So 6, backspace. I'm going to change this to 2 to the 5th. And then I'm going to, oops, don't do that. Why are you doing that? Okay. So 6 times 2 to the 5th times, parentheses, negative 2. And I can do 2 to the power of 1. And then next time I can just go and change that. So I get negative, if you can see that, negative 384. So negative 384. And then now next one, I'm going to multiply the 15 times 2 to the 4th times negative 2 squared. So 15 and 4 and 2. So instead of 6, we're going to do, I have to be able to type it. Okay, so I need 15. That's going to be 2 to the 4th, and then negative 2 squared. So that's 960. Positive 960. So plus 960 x to the 4th. And then I'm just going to remind you of something at this point, and I'm going to actually skip a little bit of it. So we would keep on going through. I just want to show you that when it was this 2, negative 2 to the power of an odd power made it a minus. To an even power, negative 2 an even power made it a plus. So this one's going to be a minus. This one will be a plus. This one will be a minus. And this one will be a plus. And then if you look at the options, actually, okay, and then there's also some numbers that are going to be repeating, because negative 2 to the 6th, if we did negative 2 to the 6th, that's also going to be 64. And then this number is going to be, if we did 6 times 2 times negative 2 to the 5th, it would be negative 384x. And then these honestly don't matter, only because if we go back to the original problem, if we look at the original question, it says, what is the remainder? Oh, no, sorry, it was not the remainder. We are on this one. Okay, so notice these are really long, right? And I'm looking at the numbers that we already had. I don't know if you remember them, but there's the negative 384 x to the 5th, and here's negative 384x. But notice that this is the only one that starts with a 64 and ends with a 64. So technically, we don't need those middle terms. You can just come right here and answer D. Hopefully that helps on that one. Okay, number 4, we were supposed to multiply those and write the simplified polynomial in standard form. I'm going to go down and do this in my notes because that's what makes sense to my brain. So this is when you're multiplying, and so we can start with that. Oops, I was putting x because I'm used to it. M plus 3, we're going to undo those. We want to go down. Plus 3 on the side, and we're going to multiply it by m squared minus 2m and plus 2. And then we just multiply. So m multiplied by m squared would give us m to the 3rd. Then m squared multiplied by this 3 would be 2m squared. 3, wow. That was so bad. Okay, 3m squared. And then negative 2m multiplied by m would be negative 2m squared. Negative 2m times by 3 would be negative 6m. And then m times by this 2 up here would be 2m. And then 2 times 3 is 6. Then the like terms are these diagonals again. So our final answer is going to be the m cubed. And then 3 minus 2 is just 1m, so plus m squared. And then negative 6 plus 2, so they're different signs, so we subtract, but there's more negatives, so it's negative 4m, and then plus 6. So on the question itself, I believe we just click and drag, right? So you would have m to the third, like that one right here, right? M to the third plus m squared minus 4m, and then plus 6. Okay. Number 5. So we're asking if this is a factor, select the two factors that express it as a product. And this is where you can do the same thing that we did on the previous one. I'm going to put it again down below on my notes because that's what I want to do. So is that a factor? Actually, this is a nice question because it says this is a factor of that. And then we're supposed to select the two factors. So for sure, on the options, you need to select the one that it just totally gave you in the problem. It says this is a factor, so you better mark it as a factor or else you're silly. So we just need to do one other. So select the two factors, check, we've got one. We only need the other one. Let's go do it. And this is the same way that we did number 1. So we're going to put the x plus 5 here. And then the first term of what we want right here. So this is going to be x cubed. So x times by what would equal x cubed? That's going to be x squared. Right? We're going to do those steps. So it's x squared multiplied by 5 is 5x squared. Well, that's supposed to get negative 4x when I combine it with those two. So I would want a negative x squared, right? Because 5 minus 1 would be 4x squared. And now we divide again. Now we divide. And so what do I have to multiply x by to get negative x squared? That would be a negative x. Then negative x multiplied by the 5 would be negative 5x. And then what do these two combine to get positive 2x? So what would I have to add to negative 5 to get up to positive 2? I would have to add 7x. And then I'm going to divide again. So x times by what equals 7? So there'll be plus 7. And 7 times 5 is 35. And then these would combine to be 35, which it is already. So that means our two factors are this one. So x squared minus x plus 7. So up here, x squared minus x plus 7, which is D. So A and D are our answers for number 5. Okay, now we're going to sketch a graph of this polynomial. I just want you to notice that this one is kind of weird. Like this would be 1, that would be 3, that would be 4. This would be negative 4, negative 3, negative 4. So you can change the window or just zoom in on your graph. But we're going to do x cubed plus 1/2 x squared minus, so x plus and then minus minus. Okay, so we're going to type this into Desmos. Whoa, why did it do that? I don't want it to do that. Clear all. Okay, so we have x to the third and then plus 1/2 x squared and then minus x and minus 1/2. Pretty sure that was it. In fact, I am sure. So I just typed that into Desmos. Now I look at the graph and I want to get points. And how do we get points? We tap, 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 tap. Lots of points. I'm going to take off some of the points because it was messy and sloppy. I'm going to get those. Are probably my favorites for the sake of looking easy. So I have 1 and -1. -1 and +1. So I'm going to come back to my graph. -1 and +1. So here's -1. There's +1. All right. Then I have -1/2 on the x-axis and -1/2 on the y-axis, or 0.5. So -0.5 here and -0.5 there. And then if you want to, from this point, you can just start making it curvy. And if this is one of those problems, so I'm going to put Desmos. This is one of those problems that if you happen to get it wrong in Savas, but you did it right on your paper, I will be able to give you full points, or you will be able to get full points. So hopefully that will work. Okay, number 7. I have a picture for it, so let's just read it first. So Tio cuts 4 squares with side length x from the corners of a 10 by 15 piece of paper. He folds the paper to make a tray that is x inches high. Complete the function for the tray's volume V. So if you're like a normal person and you did not follow along with all that, I drew a picture for you. Aww. Okay, so we're cutting squares that are x by x out of all 4 corners of this paper that's 10 by 15. And the next thing that you would do is then you would fold it along here, here, and here, and here, and here, and fold it up, and it would make a lovely box. Ooh la la. And now we want the volume. Well, I know the volume is the length times the width times the height. It told us that the height was x, right? So now if this side was going to be 10, but we cut x's out of it, how many x's did we cut out of it? Like if this whole length right here, if this length was going to be 10, but we cut x out on this side and that side, we cut 2 x's away from it. We don't know the actual length, so we leave it like that. The other side was 15, but we also cut 2 x's out of that. So now how we're going to write the volume this is how I'm going to write it, is x multiplied by, I'm going to scoot that over. X multiplied by 10 minus 2x and multiplied by 15 minus 2x. And now it's just multiplying. This is my preferred way of multiplying this one, is I like to use the claw. So we're going to do 10 multiplied by 15, 10 multiplied by -2x, -2x multiplied by 15, and -2x multiplied by -2x. And I'm going to leave the x in front because I want to... Okay, so 10 times 15 is 150. 10 times -2x, -20x. 2x multiplied by -2x multiplied by 15, -30x. -2x multiplied by -2x, 4x squared. Boom. Now the only thing we have left to do is to multiply the x into all of those. Actually, combine like terms. I'm going to combine like terms first. So then we'd have 150 minus, so 20 plus 30, they're both negative, so it's -50x. And then plus 4x squared. Going to multiply that by x. So what that's going to do is it's just going to put an x on things that are not x and make the powers go up. So it'd be 150x minus 50. Oops, I'm going to start that over 5 more times apparently. Okay, 50x squared plus 4x cubed. And then I think in the answers for this one is you would like fill in the blanks, right? So let's go look here. Yep, so this would be, Oh no, not that one. Keep on going, keep on going. Keep on going. Oh no, that wasn't. Okay, so this is 4. That was minus 50, and then that was 150. And you can stop and rewind and watch this again if you need to. Sorry that if I went too fast. Okay, polynomial identities is what we want on this one. So this is what I wrote on the board when we were in class, is since this was a cubed and that was subtracting, so the subtracting makes it a difference of, and then the power of 3 makes it cubes. That's the identity that we want. Let me come down here and write it on my official notes. Oh, I didn't do this one. I forgot to sketch it on here, right? So sketching this one, I had -1, sorry, squirrel. And then 1/2 and 1/2, up, down, up. And then I put Desmos. Okay, sorry, coming back down here. So polynomial identities, what we're going to use for this one is the difference. You put diff of cubes. And what that identity says is if you have a cubed minus b cubed, it's equal to a minus b multiplied by a squared plus ab plus b squared. So how does that help us with the problem we have? Well, I can see that this is in the format a cubed minus b cubed. So with that, I can see that the a cubed is 64 x cubed. But I want the cube root of that. I want to know what cubed equals 64 in order to get just regular a. And you can do that with Desmos. One of the ways that you do Desmos is you can do, like, you can just start guessing, right? You can do like 2 to the power of 3. Oh, that's 8. You can do 3 to the power of 3. That's 27. 4 to the power of 3. Hey, that's 64. That's what we want. Another way of doing that is you can put on the right side, there's the button functions. You scroll all the way down and there's this button. So functions all the way down at the bottom, the one that says the N, but then you're going to have to put a 3. I don't know if you can see that. Put a 3 right there and then 64 right there, and it'll tell you the answer. So there's 2 ways of finding that. So either way, we wanted 4. That's what we wanted for this problem, is a 4. So that's going to be 4x. And then the b cubed would be 1, so it's just all in 1. It's not very hard. So the a would be 4x. So in place of the a right here, we would put 4x. And then b cubed is 1. So that means that b is 1. So in the formula, we'd for sure have to have 4x minus 1, right? Because it's that same format. But then we're going to need a squared. So a squared would be the same thing as 4x times by 4x. So 4x squared, which is 16x squared. So then right here would be 16x squared. And then AB would be 4x, and then B squared would be 1. So this is a multi-select problem, and you would have to go through and select those 2. So 4x minus 1, and then the 16. So we're going to come up here and do 4x minus 1, and then the 16 with the pluses. So notice we had this one with the minuses, and then this one with the pluses, because that's what that formula was.